Now I'd like to turn it over to Vasco and Eric.
Thank you everybody for joining us this morning. I'd like to introduce myself. My name is Vasco. I'm a business development representative here at Execulink Telecom. We're passionate about delivering awesome solutions to our customers. Today we'll be discussing how to create strong Wi-Fi connection in your home office and the various technologies you can use to enhance it.
And my name is Eric Davies, and I'm a sales manager with Execulink Telecom. And today I'll be discussing the technologies you can use to plan and design your wireless network for optimal performance.
Today we're going to be talking about how to future-proof your Wi-Fi connection for remote and in-office work. A poor connection can have major impacts on your business, including decreased productivity, loss of revenue, and increased employee frustration. We'll explore the technology you can use to identify and effectively troubleshoot your Wi-Fi connection. We'll start by covering how to manage your Wi-Fi remote remote work settings in small and medium-sized business. Then we will discuss what you can do to enhance your connection in larger office spaces. We will share a case study example of a retirement facility in an outdoor marina, exploring how they enhance their Wi-Fi. Finally, we'll take your questions at the end. If any questions come up during the presentation, please share them in the chat and Susan will ask them on your behalf. We would love to get the conversation started, so feel free to unmute yourselves during the Q&A portion of this webinar. Just a little bit about Execulink. Execulink is a locally owned and operated business serving the small towns in southwestern Ontario since 1904. We have a new office in Tillsonburg located at 161 Broadway, which is open in July of 2020. Our fiber network continues to expand throughout the town, servicing both residential and business customers.
Okay, so today we are going to review some of the most common problems we face in the Wi-Fi world. These include slow or inconsistent speeds, intermittent connection throughout the day, the ability to prioritize the quality of service to critical devices, or QoS, and dead zones in particular areas. To combat this, we look at three fundamental metrics. First is signal strength. This tells us how loud the signal is throughout the coverage area. Think about a loudspeaker at a Walmart speaking over the ambient chatter of the shoppers. Second, we'll look at airtime utilization. This measures how much of the frequency is being used. Too many devices taking up space in the spectrum can cause issues. And last, we'll look at interference. This shows how other devices can add noise to the wireless network. This is like ordering food in a loud restaurant. Your order won't be heard if the music is playing too loudly. A simple Wi-Fi setup is considered a small office or a home office. In areas like this, you can centralize a single router to effectively cover approximately 1,000 square feet without any issues. However, as some of you may experience, this isn't always the case. In these situations, a solution beyond a single router or access point may be required.
Let's talk about what is a complete Wi-Fi. Execulink's complete Wi-Fi solution, the premium router and mesh Wi-Fi node, have the technology built in to overcome connection issues in small spaces like your home office. This router and node combination allows for higher quality Wi-Fi signal in your home or business with faster speeds, improved Wi-Fi coverage, and increased stability for video conference calls. We conducted an internal study at Execulink when testing the premium router to see the difference compared to traditional routers. This device has also a greater Wi-Fi coverage area, providing stronger connection in problem areas. The improved signal stability also decreases video call drops. The enhanced performance of the premium router is accomplished through auto-correcting features that improve speed, coverage in problem areas, and stability. Customers can view wireless stats for each device in their home. This allows for proper placement of your devices when installing them or troubleshooting when they're not getting the optimum speeds. With the ability to add mesh Wi-Fi nodes, we can expand your network to blanket your whole entire office. When deciding if you need to add a mesh Wi-Fi node or extend it to your home, First, you should consider your home layout and what factors you have that will influence the signal. Normally, moving the router to a more central location or an open space away from electronics, cement walls, steel doors, or enclosed areas will provide a better signal. If that's not possible, we suggest adding a mesh Wi-Fi node to those hard to reach areas. Next, you must determine the placement of the mesh Wi-Fi node. Give an example. In baseball, when a baseball is hit to the outfield with a runner on base heading home, the outfielder won't throw directly to home. Instead, they're going to throw to the second baseman, aka the cutoff person, so that the second baseman can easily throw to the catcher and tag the runner out at home plate. This is essentially how the node or Wi-Fi extenders work. They should be in between your router and your problem internet areas. If your office is having connectivity problems, adding a mesh Wi-Fi node to your office will not help. You will need to add the mesh node in between your router and your office. Now let's get into a bit more detail regarding the auto-correcting features of modern routers to help overcome Wi-Fi challenges. MIMO, multiple input, multiple output, allows many devices to talk to the router at once. Band steering will automatically select which frequency is best to reduce connection drops. Modern routers have dual band support, which means they are two Wi-Fi radios, 2.4 gigahertz band and a 5 gigahertz band. The premium router offers a unified SSID, which means that both of these bands are controlled under one Wi-Fi network. That means remembering one password and one Wi-Fi network name. You will still get the right frequency for your devices. Typically, we like to plan the network with a 5 gigahertz spectrum as the focus. As more and more devices are becoming more tolerant of the 5 gigahertz spectrum, we want to direct more traffic to the spectrum since it can handle 8 times more capacity and airtime than the 2.4 gigahertz. Now let's take a look at the image above. The image on the left shows a typical Wi-Fi router coverage, demonstrating the limitations many routers have. The image on the right, however, is the Wi-Fi signal with a premium router. The premium Wi-Fi router improves performance by reducing interference and focusing the wireless signal directly to your device using beamforming technology. Beamforming focuses the signal directly to the device rather than having the signal spread in many directions from a broadcast antenna. This technology can help improve wireless bandwidth, utilizing an increased wireless network range in your home office. Our technical support team, for example, has been following up with customers using the complete Wi-Fi system, and we received valuable feedback. For example, one Execulink customer needed internet in the shed in their backyard. Initially, they ran the Ethernet cord and moved the premium router into their shed. However, they still had coverage issues in the house. After consulting with our team, they decided to add a mesh node. This improved connectivity in the house and the shed, which allowed them to roam between both areas with seamless connection.
Thanks, Vasco. Now let's talk about larger buildings and enterprise solutions. If you're not working from home and need Wi-Fi in a larger office space, there are more in-depth tools that allow for better troubleshooting of deployments. You can leverage various technologies to identify interferers and implement solutions that will anticipate capacity growth. There are also cloud-managed solutions to troubleshoot and make changes to your network in real time. One example of these technologies is a spectrum analyzer. We recommend this solution for small and medium-sized businesses, and we would not use this in a residential application. Right now, you're looking at real-time spectrum analysis of a 2.4 gigahertz Wi-Fi network. There are 11 channels on a 2.4 gigahertz Wi-Fi. However, only 3 are typically used. Channels 1, 6, and 11, due to their distance apart from each other. Your router or access point will choose one of those 3 channels, whichever is the most free. Here, we can see 2 prominent networks on channels 6 and 11. The list below shows the many other routers that are competing. Channel 1 is relatively unused in this example. However, it gives a great demonstration of the noise floor. Noise floor is the ambient noise that can reduce signal strength and signal quality. Try talking to someone at a loud party. Sometimes you can't hear what they're saying over the other noise. The waterfall analysis on the left takes a snapshot of the signal over time. We can see if a particular channel is busy or noisy with interference. The spectrum analyzer shows us to look for interference spikes or utilization. We'll show some examples, but let's first look at some interferers. Baby monitors, Bluetooth devices, wireless headsets, appliances such as microwaves, or audio transmitters all compete for the 2.4 gigahertz network and add to airtime utilization. Airtime utilization is the metric used to gauge a channel's overall traffic. It's represented as a percentage. The higher the airtime utilization, the more congested the network becomes. Let's look at a couple examples in real time. In this example, we can see a GoPro HD camera transmitting data. Channel 1 becomes flooded with that data. If our network was on channel 1, we would certainly experience some slower speeds and possible lost packets. As business owners, we sometimes cannot control what devices our employees or customers bring into an office, but these devices can have an impact on our overall network health. In this example, we get a glimpse of how a microwave can wreak havoc on a network. Pay special attention to the fact that a microwave does not confine to an individual channel and can have a negative impact over a broad range. This illustrates how an everyday appliance can impact the quality of your Wi-Fi network. Next is a cell phone sending a file via Bluetooth. Notice how Bluetooth hops along many channels with those half peaks across the entire spectrum. This is actually in an effort to avoid interference. Think of it like skipping a rock across a lake rather than doing a cannonball. It can still cause interference and will add to a channel's airtime utilization, if only for a brief period of time. The past examples have shown how interference from other devices can impact our wireless network speed and health. Let's now take a moment to look at maybe the most important factor that contributes to your wireless network's health: placement. Identifying the best spot for a router or access point is crucial, and signal strength can be demonstrated in this visual. When planning a wireless network, begin by understanding your coverage goal and place your router or access points where people need connectivity the most. Then, get as many devices on the 5 gigahertz spectrum manually or via band steering as possible, and eliminate as many interferers as possible. Let me now walk you through a case study where we were able to bring all of these concepts together. Okay, the challenge we faced in this scenario was a long-term care facility that was experiencing VoIP calls dropping, dead zones, medical equipment unable to connect in some areas, and guest devices crowding the network. You can see in this map areas that needed attention noted in shades of red, and areas that coverage was acceptable noted in green. The gray spots represent absolute dead zones. In this scenario, the customer had placed entry-grade routers around the building in areas that weren't necessarily ideal and did not effectively separate the Wi-Fi channels, so there was a lot of competing interference. Our customer placed the routers in central areas, so signal strength was poor in hallways. That was problematic because that was often where people needed to connect to their equipment. Now, you can visually see the quality of signal is spread a lot better through the building after we deployed our Wi-Fi solution. We placed access points where they would be most used and covered hallways where dead zones were before. We set all access points to channels where they wouldn't compete for signal or experience channel interference. We also set up band steering so modern devices could connect automatically to the 5 gigahertz band when available. Additionally, we established Wi-Fi priority for mission-critical devices. In this case, they're VoIP phones. This is known as QoS, or quality of service, and this prioritizes some applications, such as voice, and deprioritizes others, such as streaming or gaming. All of this led to a very healthy wireless network and a happy customer. For this next example, we'll use a larger outdoor space, a marina. Execulink was requested to give a full survey and determine the best way to provide a great Wi-Fi solution so boat owners could enjoy video streaming right from the comfort of their boat cabins. There are a lot of unique challenges at play here. Obviously, primary and secondary coverage is important. Capacity is a consideration due to the volume of boat slips. And unexpectedly, there was a lot of interference from the boaters to account for. In order to provide a high enough throughput for video, we needed to have wireless signal strength at or above 70 decibels and accommodate the wireless networks for a large amount of people to use at the same time. These are metrics we simulated with Ekahau. But first, let's look at the physical layout of our survey area. In this map, you can see our path around the boat slips indicated in green. And prior to this survey, we set network requirements. So when we pull up our visualizations, we will be looking at them with our requirements in mind, since every situation is unique. There are two ways we could simulate and plan a network this large. The first is the built-in AP Auto Planner, which places APs on a map based on a customer's specific requirements, as well as taking into account signal impeding obstacles like walls and shelves. This gives a great idea for coverage options in offices and indoor spaces. The second option, which we used at the marina, was the AP on a stick method. We love this method even though it's more time consuming, as it gives true real world data without any building and infrastructure costs. This is an example of an AP on a stick. We are able to place a physical AP in a location of our choosing or based on Ekahau's recommendation, then survey the area around it. And Ekahau maps all the required metrics with that AP in place. When we are satisfied with that AP location, we can freeze it, move the AP and stick to a new location, and repeat as many times as necessary to create a multi-AP deployment while only using a single AP. The result is a tangible map with true-to-life results, because we were able to situate an AP in a position as if it was installed, but without incurring installation costs and move it around as needed. This is something that Execulink has found to complement the service and something we are very capable of doing. Let's look at the real-world results of our AP on a stick method. We can see our primary signal strength meets or exceeds 70 decibels in the majority of areas. This gives us confidence that if we properly configure the wireless network, our range should be enough to supply streaming video in this entire area. Again, we will take the secondary coverage into consideration as well and see what the coverage will look like if any individual AP fails or is out of service for an update. Here we can see that the majority of the slips are still relatively covered, with the exception of the wing of slips on the far right. Since we're unable to deploy an AP on the dock due to customer restrictions, if that AP were to fail, they would no longer have adequate service in that one area. At a glance, we can also look at pass-fail requirements of overall wireless network health, indicating the spots that need attention noted here, with some reasons identifying why those areas failed. The beauty of this planning tool is that we can do all simulations, planning, and adjustments without any infrastructure cost and very minimal commitment to hardware. It's like a perfect solution discovery without commitment, which is an amazing thing. With this particular case, the failures were due to inadequate secondary coverage. This is sometimes unavoidable based on customers' price point or requirements. We could easily add a redundant AP, but sometimes customers may decide it's not necessary. One thing we gained by doing this survey is we discovered the surprising amount of boat owners have wireless repeaters plugged in. This interference dramatically changed our deployment approach, and had we not surveyed, this would have required a lot of reinstallation and troubleshooting. Okay, so we've covered a great deal of material today. Let's recap some of the key points. First, to enhance coverage in a home office, consider adding a router with mesh capabilities. Second, take advantage of the auto-correcting features of modern routers to overcome Wi-Fi challenges through beamforming and band steering. Next, we discussed how much competition there is on the 2.4 gigahertz network by items such as baby monitors, Bluetooth devices, wireless headsets, and appliances such as microwaves. We also discussed how identifying the best placement for a router or access point is crucial to sustain connectivity. And lastly, our case studies demonstrated that you can troubleshoot larger Wi-Fi deployments using a spectrum analyzer and other tools from companies like Ekahau.
Thanks, Eric. And I want to thank everybody for joining us today in this webinar. We are passionate about delivering Wi-Fi, and we hope you learned a little about your Wi-Fi network, whether you're working from home or in the office. We'll now be taking questions that you may have.
So I'd just like to remind everyone, if you do have a question, please indicate that by putting it in the chat located at the bottom of your screen. And I do have a question. I'd like to get that started if that's okay. Could you just explain again what you mean by the mesh capability router that you talked about for home office use?
Yeah, sure. Basically the mesh router or the mesh node, what it allows you to extend your Wi-Fi coverage to more space. So like we described in the example, if you put the mesh node between your router, for example, in my home, I have the premium router in my basement. In order for me to get more coverage in the upper floors, I put a mesh router in the main floor, which gave me coverage for my entire house, so I can reach different places throughout the home.
Okay, perfect. Thank you. Is there anyone else who would like to clarify any one of the slides shown and comments made today? Just please do put it in the chat. Or unmute yourself if you would like to just ask a question, and I'll...
Can you hear me? I have a question I'd like to ask.
Yes, this is Bruce speaking.
Yes.
Okay, Bruce, please go ahead.
So Vasco, it's Bruce White. So the question I have is, I've seen, or we've used in our home through our IT person, this item that plugs into your router and into the regular electric outlet in the wall, and then the other port goes into another wall somewhere else, and you plug your Ethernet cable right into that. So do you have experience with those, and how well do you find they work? Do they work as well as a mesh router?
Yeah, those would be the extender, I believe. And by the way, hi Bruce, nice to talk to you. Yeah, those would be the extender, and it's similar to the mesh node. The mesh node, basically, when you plug in into your space, let's say you have it, for example, like I do in my living room and the router downstairs, it starts to basically get data from your router, and it will suit your best ability to get your Wi-Fi throughout your home. So I think it took about 24 hours for the mesh router to get all the data, all the specs and everything that it needed, or the mesh node, sorry, so that my Wi-Fi was working optimal throughout the house.
Okay, so then just a quick follow-up question is, if you have a router broadcasting at 2.4 and 5G, should you put all your devices on the 5G channel for balancing?
They will roam between the 5G and the 2.4 gigahertz, depending on what you have your specific hardware piece, whether it's your phone, your laptop, what you have it hooked up to. I, for example, have mine hooked up to the 5 gigahertz spectrum.
Okay, that answers my question. Thanks, Vasco.
No problem.
Thank you, Bruce. Is there anyone else who would like a question? Like to ask a question? Please either unmute yourself or show it in the chat. Thank you.
I have a question. Is it possible to stop Wi-Fi interference entirely? Is there anything that you can do to stop it completely?
Yeah, I'll answer that. Unfortunately, no, it's not possible. Many households have devices and materials that can cause Wi-Fi interference from your TV, your neighbor's router, your oak TV stand, or other items throughout the house, your furnace, or even your microwave. With that in mind, you can try moving the router to a more open space, or talking with us to see if an Execulink mesh Wi-Fi node will be a better solution for your home.
And I actually see there was a question in the chat.
Yeah.
It looks like someone asked, what is the max distance between the router and mesh node in a typical 2-story home? And what would be the max area of coverage for this system? So I would say that's a hard question to ask, because depending on what the building materials of the home are and where the equipment is located, you know, if you have a standard home that is a drywall and lumber construction, that's going to be different if you have steel studs or masonry inside. But in a typical two-story, what we find in a typical setup, and I have this, and I believe this is very similar to what Vasco has, is a typical two-story where you have 2 levels plus a basement. What we found is one of the routers and one of the mesh nodes will normally provide very good coverage in the home, as well as into the outside of your home if you have a patio or you want service in your garage for some reason. So you're typically looking at one of the base routers and then maybe one mesh node. Now, as far as the max capacity, you can put up to 5 nodes on the router. And with that many nodes, you could easily cover a space in excess of 5,000 square feet.
Thank you, Jeff, for the question. Is there anyone else who would like to ask something? Well, seeing none, Eric and Vasco, do you have any further comments to make before we say goodbye to everyone?
I'd like to thank everybody for joining us today and learning a little bit more about their Wi-Fi needs, whether it's in their home or their office. Thank you very much for being here.